Hey everyone, Chris Kuzmal here. Today we're going to begin implementing the counting sort algorithm from Corman, Liserson, and Rivest. We're going to do that in a brand new REPL. If my keyboard behaves, actually if my mouse is being overly sensitive, and so it's receiving my clicks a little bit more vociferously than I would like. So if I burst out cussing, that's going to be why. So we're going to call this counting sort as our REPL. That's a Java REPL. And the counting sort is going to use three helper methods. The first helper method that it's going to use is a classic in introductory computer coding classes, and that's a histogram. Public, static, array of integers is what we're going to get back from our histogram method, and what we pass to it is an array of integers. And what's going to happen is we're going to produce an array. Now let's zoom in a little bit. Oh, look, I misspelled histogram. Is still unhappy because I'm not returning the promised array of integers. So I make an array of integers. Oh my God. But I don't know its size. Do I know the size? You see, the histogram, I haven't explained what a histogram is. I'll call the size of it h size, and we're going to have to compute what h size is. For the moment, I'm just going to say h size equals 0, which is clearly wrong. And I'm going to return retval because what I want is for my histogram method to function as primitively, as basically as possible. In other words, I'm implementing the most stubby method I can, subject to the requirement that it returns an array of integers. And so to test it, really what I want, well, I'm debating. I'll go ahead and do my documentation, my initial commenting. The input is going to be an array of integers that have repeated values. I mean, technically you don't have to have repeated values, but that's the expectation. The output is an array of integers containing the number of each element in A located at that element's index. Okay, so and we'll give an example. It's a little hard possibly to imagine what this could mean if you just looking at it from first principles. There's a small number of people out there who like to have these definitions given to them and then they can just run with them, and so I like to do that. The effect is that we don't really have an effect. So we're not modifying A or anything else. So there's no side effects from this method. And, you know, the mathematically oriented coders like that kind of thing. So now the question is, what's going to be proper behavior? And so we're going to have a histogram test that we're going to invoke, okay, from main. And public, I guess I can make it public, static, histogram test, number 1. And we're going to have our input array we want some repeated values. So what we're going to have, I'd like to do kind of P, 3, 1, 4, 1. That seems like a nice, pretty basic. It's not the most basic example, but we've discovered already that sometimes your test cases that involve arrays of size 0 or arrays of size 1 actually typically test boundary conditions that are a little bit harder to work out than otherwise. So our expected value. So here's kind of by example what we're looking for. How many zeros are in AR? There's no zeros. How many ones in AR? There's 2. How many 2s in AR? There's 0. How many 3s in AR? There's 1. How many 4s in AR? There's 1. And that is the histogram of AR. Okay? And so when we compute histogram, so int AR actual equals histogram. Someday I'll be able to type AR. Then we basically ask if same, for using our old same method, AR actual, then we passed. And else we fail. Oops. And as usual, we print out our result. Our number of passes, our number of fails. And I probably should edit out this because we have watching me write this code 1 time or 2 times or 3 times is probably fine, but you're probably getting sick of seeing me write the system out print line. And I'm getting a little sick of typing it too. So if only we had a lovely way of encapsulating things. I'm going to pop over and snag the same method for better or for worse. The same in the toString method for arrays. This is where library functions are valuable, but we're trying to keep it within reach of beginner programmers. So for those of you who've seen other of my videos, I understand that you may be a little bit fatigued. Right, we never invoke toString, but we do invoke same. So there's a little complaint here. It's little amber underlining because the toString method is never called. But we can fix that by when we fail. If and when we fail, we can print out the actual array, the expected and then do toString of expected and then the actual and the toString of actual, and that might be correct. All right, so the good news is this test code should work, should run, but I don't expect the code to succeed because the histogram method is a stub. But that's probably good, right? Because we want to see failure. So we zoom out, we click run, and oh, I didn't declare histogram properly. I did public static, wait a minute, histogram test is void. Histogram test simply modifies pass and fail, which I didn't initialize either. So let's go ahead and do int pass fail, but those need to be static, don't they? Right? We keep relearning these methods, relearning these stories. And h size, which was clearly wrong, we never, well, no, oh, I forgot to declare h size. I said h size is 0, but I didn't say int h size equals 0. Another basic lesson. And there we go. We had failure, we have an actual array of length 0. This is exactly what we were looking for at this stage. Now we would like our histogram method to actually work. What it's supposed to do is supposed to count up the number of items in A of each kind. Okay, and so first thing we want to do is find out what the largest value in A is. Okay, and so that's a helper method too. So H size is just going to be the max of A. All right, and so I'm going to make a public static int max method that takes an array of integers. And what I'm going to do is I'm going to iterate through it for each element in A. If E, that element, is greater than what we thought the max was, then we're going to make the max equal to E. Okay, and we're going to return max. Now there's a problem, of course. Max has not been declared, so we do max equals A of 0. Now there's a problem if A is not has a size of 0. In fact, we'd have a problem anyway, so I'm kind of content to let us have an index out of bounds error here. Probably I should do something cleaner, but I think I can live with this. So the good news here now is we can do a test case. Even sort of there's a meta level meta test case or a preliminary test case. When we run, remember we had an array of size 0 when we ran successfully before. Now it can't find x, max of x. Where's max of x? Why did I write max of x, and where did I write it? The place I wrote it apparently was on line 45. Max of x? I don't want the max of x, I want the max of A. Okay, go figure. And so here the good news is that we have done a count of the actual elements, but you'll notice that we're actually off by 1. The number of elements that we allocated was the maximum of the set of values in the array, but what we actually want is 1 more than that because our indexing is off by 1, so it's going to be max of A plus 1. Okay, so that's clearly not wrong. I'm very confident that that's correct. We'll go ahead and run it again. Now we have a lovely array of size 5. The array's sizes match, and that's actually a nice little test. If I were being a little bit more rigorous, I would actually write a test that determines whether or not the size of the return value matches the size of the size we would expect. But I'm not doing that. I'm being lazy. And we go back to the histogram method, which now has figured out what the size of retval should be. Now we need to iterate through retval, I think. We need to iterate through A for each element in A. I don't know whether we're going to get away with doing the a for each loop, but we'll try. For int E in A, what do? We basically want to say retval at location E. So E transforms from a value to an index. That's sort of the cool thing about the histogram method. Retval of E gets incremented. We just do plus plus. Okay. I think that's it. Let's see whether or not this passes. Okay. Well, it complains. The expected was 02011. The actual says 02011. So it's still claiming to fail, which is sort of interesting and slightly disturbing because we would have expected that to be same. Oh, that's because we're comparing AR to actual rather than expected to actual. So our test code is wrong again. All right. And it passed. Hooray. So the good news is we've implemented the histogram method, which is a classic kind of mini helper algorithm that you learn in an introductory class. But, you know, that's enough for now. We've been talking for 15 minutes. We'll do another video.